Good morning, ladies and gentlemen, and I hope there'll be more of you by the time the speaker gets up here, or at least finishes. Welcome to Grand Rounds. Next week, there's no Grand Rounds because of the Thanksgiving holiday, and so the next time we'll convene in this way is on the 29th of November, when our own Bill Pfeiffer will be presenting. Just want to mention a couple of announcements. Dave Latoff, one of our PGY4 chief residents, received the Ginsberg Award for Excellence in Teaching from, I think it's the APA subspecialty component. Is that what it is? No, ADPERT. Oh, ADPERT. Okay, well, that's the training organization. And Katie Brewster, from our PGY3s, received an award, fellowship award from the American Association of Geriatric Psychiatrists. So, these are really distinctions that are commendable, but what I find also pretty gratifying is that they're in geriatric psychiatry, which is an area we haven't done enough to populate. We have a really good Grand Rounds today in the sense that our speaker is really somebody who's enormously well qualified to comment on an area that's really kind of a disruptive discipline that's impacting the world, but including healthcare, medicine, and science in ways that it hasn't before. That's Dr. Deborah Estrin, who currently holds the title of, where did it go? It's something really long and important. Associate Dean and Professor, Cornell Tech, and co-founder of Open Mental Health. I'll do better in a moment with that. But it's, I think, somewhat ironic that she's here today when this week the news story that's populated relevant to this, at least that I've been contacted to comment about, is this new FDA-approved medication, which basically is aripiprazole, Abilify, nothing new there, but it has a sensor embedded in it from a technology company called Proteus, which when ingested emits signals that can be detected on a smartphone by up to 4 individuals, including presumably the healthcare provider, the doctor. And, it's from the standpoint of mental health care, well, all of medicine, treatment adherence is a big issue, but for that of mental health care, it's kind of the first kind of introduction of a technology into clinical practice. Now, it's a tsunami that's waiting to happen. The FDA knows it, healthcare systems know it, but it's on the cusp, and this is really the first sort of example. I'm not sure it's going to be that consequential, but that remains to be seen. In any event, Dr. Estrin is a graduate of UC Berkeley, and then from MIT at Berkeley, she received her undergraduate degree in computer science and engineering. At Berkeley, she received a PhD in the same. She then returned to California and was on the faculty at the University of Southern California, rising to the level of computer of the computer science department and project leader on the USC Information Sciences Institute. But then she moved crosstown to UCLA, where she similarly rose to become the professor of computer science, and also co-founder of the Open mHealth, a nonprofit startup. Oh, wait a minute, that's the next phase. So from UCLA, she was recruited back to the East Coast, and that was really an interesting recruitment in the sense that many of you may remember that Mayor Bloomberg, in an effort to try and bring technology to New York, which had sort of missed out, had established this RFA competition for the local universities to operate and develop a technology institution or capability on Roosevelt Island. And Cornell won the bidding or competition, and Dr. Estrin was one of the first recruits in this context. And she now holds the position of Associate Dean and Professor of Computer Science at Cornell Tech and a Professor of Public Health at Weill Cornell Medical College, and she's the founder of the Health Tech Hub and directs a small lab at Cornell Tech and the co-founder of a nonprofit startup called Open mHealth. Her work is really exemplary, although not the kind of thing we would usually read, but as I said, it's something that's going to increasingly be relevant for us. And I just thought I would read a couple of her publications just to give you a flavor for what she's been doing. So personalizing software and web services by integrating unstructured application usage traces, latent user interest profiling from visual contents analysis, smartphone data in rheumatoid arthritis, what do rheumatologists want? Published in the American Journal of Preventive Medicine, the pace of technologic change, implications for digital health behavior intervention research, and reassembling our digital selves, which is something I'd like to find out how to do in the discussion afterwards. You may expect that she's been recognized in terms of the work that she's done over the course of her career, and I'll just mention three that are really the most distinctive. She's been elected to the American National Academy of Engineering. She's a member of or fellow of the American Academy of Arts and Sciences, and also a fellow of the American Association for the Advancement of Science. So please join me in welcoming Dr. Deborah Estrin.
So it's great to be here. And while, so I needed the water. While what I'll talk about is not unique and certainly not entirely about psychiatry, I can't think of a clinical context to which I would hope it would be more applicable. And in most of the talk, I'll refer to work that was done with lots of people over the last decade, including many former colleagues at UCLA, UC San Francisco, colleagues from different institutions, commercial, nonprofit, Sage Bio Networks, I'll mention them a little bit later. And the organizer, whoever that is, has my PDF of my slides and happy to send them to you. I'm sure I won't get through all of them. And feel free to interrupt with questions if it seems like it's something I'm getting to. I'll just let you know. So to start by putting it in context, we have been reading about big data in many contexts for building predictive models. And it's a huge focus across medical schools and from departments, not just in clinical informatics, where a lot of it began, but in radiology and genomics and psychiatry and public health. And what I want to talk about is a complementary, not instead of, but a complementary key opportunity at the individual scale. So what I started calling small data, not a great term, but I'll try to now elaborate on it further. And what I mean by the small data are the data that are captured and analyzable from a patient's mobile phone as well as other online digital interactions. And the idea is to use small data for patient care and for research before you go out to patient care, that you do this research and eventually a patient care by being able to access those data, process, and most difficult of all, interpret it in some meaningful way across these data stream and in different contexts. And that's about as general of a statement as you can make until it gets down to sort of the specifics of what is the patient being cared for and by whom, and what are you trying to understand. So initially, and even now, it's really most important for individualized disease management and to some extent for health behavior change. And I would say only in the longer term for diagnosis. So if your antenna go off around worrying about that something I say seems like that is not credible as diagnostic, that's really most relevant, it's very individualized, and it's relevant to somebody's baseline, yes. So if I forget to qualify every statement I make by that, please give me the benefit of the doubt and interject that, or when we get to Q&A, and otherwise let's go back and be very careful about it. So I originally told a story about this a number of years ago in a TED Med talk, and it was shortly after I came to New York City. and joined Cornell Tech. And if I have time at the end, I'll say a little bit more about this shiny object in the middle of the East River. And when I look back at that now, we're almost at 2018, so it's, 5 years ago I was slaving over how to construct this TED-Med talk. And at the time, I really thought it was a bit too here and now for TED-Med, where, that stuff tends to be a little bit more futuristic. I don't think of myself as a futurist. If things take a long time, it's because we failed to do it sooner, not because I intended to be projecting so far out in the future. And so when I told this story, I thought it was a bit too here and now, but still working to make it true along with a large community of others. So I guess it was much more futuristic than I thought, but not for good reasons. So at the time, just in a snippet, I was telling the story of my father's decline, because in every TED-Med story, you have to put in some personal thing, and there's a whole cadence to this silly thing. But the story wasn't silly, and it was true. It was that I told the story of my father's decline during his last months of life at age 90, and in retrospect, as we were trying to understand when this last phase of his life that resulted in him passing away, when that had started, it was clear to me that these things were apparent in his behavior and in his digital traces. So a reduced range and frequency of his daily walks, a reduction in his, and eventually not anymore, buying groceries to prepare simple meals at home, but rather entirely eating out, and a reduction in his responding to emails and so forth. And lots of people, said at the time, "What are you expecting from a 90-year-old? 90-year-olds aren't using email that much anyway." But my father was in the early community as the ARPANET was coming into being, and one of the earliest email users there were. So this was and there's an example of where this is very. It matters a lot what somebody's individual habits and behaviors and use of technology is, and it's relative to that all of these things hold their most promise relative to somebody's baseline. So I commented in that TED-Med talk that neither his cardiologist nor an emergency room doctor thought that there was anything unusual, because he really presented well for a typical 90-year-old, right? And you guys all know these stories, but he wasn't a typical 90-year-old. He wasn't presenting well for himself. He was presenting significantly worse than he had been a month before. So by small data, it's those digital traces, the information about that N of one, about that individual, that if interpreted and could be used in loops of care. And so, you can... a way to capture this also in terms of its complement to all the important work that's going on in all the omics from, genomics, metabolomics, whatever it is, that this is really about helping to fill that gap between what patients are born with, genetic makeup, to what we suffer from. So I think it's most useful to think about these data in the context of how those data would be used. And so, if you will, the feedback loops of health. So in thinking about the feedback loops of health, right, there was this conversation with the cardiologist or the ER doc, cardiologist even more relevant here, right? So how does somebody's clinician use information like this to look at how the patient is responding to a new care plan? And some of you I already talked with earlier today, and there's work going on here and in many other contexts where that's what's being done. You're trying to bring more objective data to inform better clinical care, whether it's drug titration or selection of an alternative treatment plan altogether. And the community has come to refer to these things as digital biomarkers to complement traditional biomarkers. And these are intended to provide high resolution, accurate, and rapid, in some cases, feedback to practitioners in support of disease management. So not diagnosis yet, again, and importantly. So I think for psychiatry in particular, this has great relevance to patient care, from more severe illnesses, schizophrenia, bipolar, to more common anxiety, depression, and addiction management, which is so much of the great work that you guys have been doing here for decades. And in many contexts, it's about taking that great work you've been doing for decades, using other technologies or other protocols and other instruments that are on pieces of paper or as instructing individuals, and taking what you know and had evidence around and overlaying that onto these new delivery and deployment platforms. That isn't necessarily how the startups in the world, at least the first wave of those startups, went about doing their work. They went about making some observation and saying that going to see a psychiatrist and having care doesn't look like buying a car, right? This is the typical stereotype of Silicon Valley, right? So we should be able to make, getting your psychiatric care as effective and easy as buying a car. Okay, just an absurd an absurd banner under which to try to move things forward in a significant way, which is why I think we're not in that much different of a place than we were a decade ago, okay? Whereas the way to do this well, and why you guys are the ones to really to do that, is to take what you know, to take clinical measures that you have evidence around, and allow for the perhaps reduction in precision or other, suspend a little bit of disbelief to try to take on things around the new technologies. So I could stop there. That's the primary message I would like to give, but I'll keep going because I'm supposed to fill the 50 minutes. So, when I'm sure some of you saw this Atul Gawande piece in The Atlantic early in the year. And again, this isn't by any means just about psychiatry, medicine wide, and it was where he talked about incremental care and pointed in particular to the opportunity of using individuals' data to do data-driven precision disease management and prevention, and using the data that people generate as an evidence of their function, their response, and their phenotype. So I really enjoyed, we all, I assume, like reading things that are confirmatory of our own belief system. So his quote in particular, and of course, any moment in which you use his articulate wording is better than what most of us can do. So let me just bear with me in this one reading of his quote. "We can shift our focus from rescue medicine to lifelong incremental care, or we can leave millions of people to suffer and die from conditions that increasingly can be predicted and managed. The more capacity we develop to monitor the body and the brain for signs of future breakdown and to correct course along the way, to deliver precision medicine, as the lingo goes, the greater the difference healthcare can make in people's lives, as well as in reducing future costs." And it was a lot of fun to see him interviewed, Francis Collins. There was a conversation between Francis Collins and Gawande, in which Gawande was trying to convince Francis Collins that, okay, good, you guys, you did the genomic stuff, right? But what about this other, yeah, exactly. So it was sad and funny. Okay, so, and one of the things that I want to now talk about some of these data sources, while eventually there might be things that are more directly from the brain, right? He mentions that monitor the body and the brain for signs of future breakdown. There are things that we can do now that are proxies for monitoring the body and the brain. Another point that I'll try to drive home. And then a lot of what we need to do, I've been using this figure for a long time to point out the difference between clinical care and participant self-care, right? You give drugs and say take as needed. How do you know when it's needed? Or your patients go off and try a whole bunch of stuff that they buy at online or at Whole Foods or wherever it is that they believe has some therapeutic effect. And how do they? And you can either say none of it has any therapeutic effect, or maybe it does for them in there some way. And so you can close the loop of having individuals be more systematic, whether they're trying to understand if they're sensitive to gluten or whatever is their personal story there. And then research evidence. And I used to just sort of mention that at the end, which is indicative of saying, what works best in different contexts. And I think ignoring this loop is also part of why we have not made the progress we could have. The technology is all there. It's in everybody's pockets. People are online way too much. There are plenty of digital traces. But the the careful but not painstakingly slow development of research evidence has not been, I think, what it could have been, in part because we ignored it and tried to jump too quickly ahead. Not you, we on the technology side. So what do I mean in terms of these data sources? I'll just at high level here, and I'll say more about each of these over the next few slides. So diverse data sources, and I think the place to start is by looking for approximations to established clinical symptoms, side effects, and behaviors. In the longer term, there'll be some big data look, getting a whole bunch of this individualized data, meeting up with a deep neural network, and you will find some discovery of some new patterns that are not yet known. That will be very exciting, but it will be very opportunistic in the way that most machine learning and data stuff is, because it can only find things where you have access to that data. And there are a lot of people who could be much better cared for in the meantime by not waiting for that big data diagnostic story and not coming up with some surprise finding between things. You guys already practice and care based on established clinical symptoms, and we have the opportunity to match the technology, not to come up with new findings of clinical symptoms, but to help you do a better job of monitoring those symptoms or detecting changes in those symptoms when somebody is not directly in your care. So all of these data streams I'm talking about would be ways of extending things that you're doing now. And if that sounds incremental and not transformative, I either disagree or don't care, right? I don't care about that word in that case. I think that looking for the places where this can be an effective way of extending, scaling care is a great thing to do. So I'll say a few more words about passively recorded activity and location data, largely off of mobile phones, real sensors, because real sensors somehow need to be individual, special purposed devices measuring a particular physiological or physical parameter, and that makes them interesting in some ways and less interesting in others because they're specific. I'll say more about that. Self-report, which at any point in time, there are a bunch of things we can now measure better without it, and there are a whole bunch of things we can't measure without it. So can we just do better at self-report, even if we can't do away with it? And then digital traces more generally that aren't based on specific devices. Okay, so as an example, passive location and activity data. So these can be used to observe many features of social rhythms, and social rhythms and patterns are very relevant to what you do. And this goes well beyond, but does include sort of how many steps per day. So the story earlier, I've lost all track of who told me what story in the 6 people that I was talking to, but the story of that there was an indication of people becoming extremely sedentary. It's you. And that is both a symptom and a cause of increasing problems with depression. It's reinforcing. And you can do that with a Fitbit, right? You can also do that with somebody's mobile phone. And it's not just whether they are taking steps or getting up from, to go from the couch to the kitchen. It's also these a little bit more gross location patterns. So what time are they getting up and out of the house to get to work or school? Is there a shift in how many days they are out of the house? How many hours they spend out of the house on a typical day or weekend, and what's the diameter of their day? So there are these larger scale things that, since our mobile phones, for the most part, are tracking location, is a readily available social rhythm cue, and you can actually do these things without literally tracking individuals, right? So if the thing goes off saying I work with particularly, individuals who tend to be more paranoid, they don't want to be tracked, they think they're being tracked anyway. There are ways of doing these things that can be more or less privacy revealing, or I don't want to be liable for knowing where everybody is at every moment. I would argue that we should figure out, is this stuff actually useful, in what cases, and how do we use it to be useful? and those other parameters that introduce friction, we can deal with in different ways. And of course, all of these things are irrelevant if it's not relative to somebody's baseline, right? Somebody who is on a night shift looks differently than somebody on a day shift, somebody who works from home. So don't worry about a one-size-fits-all. Worry about that. Think about this as something that helps relatives to somebody's baseline. Are they getting better? Are they getting worse? Are they in a relapse? So from an actual device perspective, there are now wearables adopted in clinical trials. You can include that in your IRB. You do. There are results out already from those clinical trials, and whether it's a less expensive, just quite inexpensive by now, a wearable, which is going to be much better for people who tend to spend more time at home, the elderly, devices that measure sedentariness at home is important, whereas the phone is, people leave it in one place at home, right? Whereas it's people who are out and about still actively working, studying, that the phone can be better than a wearable. And then there are more specific wearables that have been detected for certain things. Just as an example, Empatica from a spinoff from the Media Lab at MIT has been used for seizure studies. It came onto the market initially, or as a startup, was going to be very general. And as with many of these things, you have to go down to the very specific to find a place where the particular signal is really useful in clinical care. And in general, it's better to go to the very specific, really show how it's used, and then maybe you generalize and reapply it in other contexts. So in the scheme of this sort of real sensors, or Internet of Things, a term you might have heard, IoT, one of the more interesting things than the wearables even are these voice agents that come out of little hockey puck or cylindrical things that, if you had asked me N years ago whether people would buy an Amazon Echo to sit there and to talk to it, I would have gotten that one all wrong. But it turns out that, and in retrospect, when you hear about it afterwards, it makes some sense that even in populations where they're not taking to touch screens and this sort of technology anyway, talking is something that most of us have evolved to do. And so, you're talking to the cylinder instead of talking to a person. And those of you who worked in IVR have known for a long time that voice interfaces can be much more general. And so this is just the latest of these, now driven by huge amounts of data in these centralized commercial entities that we now have in the world, for better or worse. And the better part of it is that they are able to train much more usable and seemingly smarter interfaces, so that IVR isn't sort of difficult to do as before and very sensitive to accents and such. They've gotten so much better, these voice interfaces, over the last few years. And so interesting from a interaction point of view, from a self-report perspective, as well as to some extent from what you can learn from language use and voice signals over time. Although getting the raw data about the voice out of something like Echo is not what you get. What you get is language out the other side. Yeah.
Voice-activated personal assistants. The wearable device collects data or can serve for communication purposes. How does Alexa sort of serve the purpose of acquiring this broader profile?
Most of these things that look promising, I think, come from the consumer world, that people want to use them for something else. And then there are ways for you to come up with ways of leveraging that, okay? So an Amazon Alexa is a black cylinder that looks like that, or, a Dot, a little one, and an Echo, a bigger one. And Alexa is a voice agent, and it sits in your kitchen or living room, and you say to turn off the lights, or, turn on NPR, or, read back your affirmational self-statement that somebody told you to make every day to try to improve your adherence. I'm making this up, right? To not going out and drinking that evening, okay? All of those things can just be programmed in. So any of you heard of Health Tap? So Health Tap is probably one of the most successful companies in this space of bringing larger scale clinical feedback in care, like a hell of a lot better than, I am being recorded or webcasted, right? A hell of a lot better than some consumer websites that are all advertising driven that your patients might go to find about disease X, Y, or Z, okay? Much more curated, real clinician input. And over the years, HealthTap, they now have an Amazon skill. So you can talk to HealthTap through this interactive device. So just think of it as, I mean, I don't like talking to objects. I would much rather tap on my phone. But there are different people in different contexts. So I'll say more about that in a little bit. Yeah.
With data that's collected through the wearables and the biosensor devices, it's clear how that data stream would be sort of converted or interpreted into some.
Yeah, grammatical complexity, idea density. I mean, there are things in language. Does that, no?
Yeah, forget what I said. It's a simplistic question. Go ahead.
Okay, ask me at the end. Okay, sorry. So I talked a little bit about sort of passive location activity streams, the most pervasively available from mobiles, and then some specialized devices. And then if you're doing something specific, the more specialized your device, it really has to be that somebody's going to want to wear it all the time, and you're going to have to give them some benefit from it to get that more broadly used. I'm a huge fan of specialized devices. It's just sometimes people want to wait for a specialized device as opposed to a proxy measure that can measure the same thing while you're waiting for that specialized device to emerge. Self-report. So in some sense, all of these passive measures from our wearables or devices are, instead of augmenting asking somebody, but it's not to be in, when you're asking somebody because you have no other way to get an indication of how they're doing, right? Then if you have ways that can be, that can avoid retrospective bias and the difficulty of remembering or the inability to detect whether you're in 10% or whether you're 15% less pain than you were a month or two ago and you're under some slow course of treatment, or whether it's meditation or yoga or back exercises or acupuncture. These things don't have dramatic step function effects. People are still in pain, hard to report that you're 15% less. So, but there are some interesting ways of moving from the standardized promise-like instruments that are all text-based to move to instruments that are more visual, personalized, just more rapid to do. And so Pam developed, my now colleague, but this was done during his PhD work with Jerry Gay, developed Pam. Any of you seen this? Any of you use it? Unfortunate. It's a photographic affect meter. And this is probably the only thing I'll show you that has been validated. There's a paper from a number of years ago where it's been validated against, I think, Panis and PHQ-9. And what you do is you just, the app pops up, or you're reminded to open the app with a text message, and you tap on the image that represents your mood. Those images are not randomly placed. They're according to the 2 dimensions of affect. There again, this is research you guys in your community did, right, to establish these 2 dimensions of affect, high, low energy, positive, negative. And it's taking what these decades of work that you folks have done and projecting it onto modern technology. 2 dimensions of affect. Now can we do that with images? So this was done initially when Flickr and a lot of online photo sharing was just starting. They curated a whole bunch of images. They had a bunch of individuals sort of classify images and got rid of the ones that were inappropriate. So they have a large battery of images, and it's not always the same ones that show up. It's randomized which one shows up in the upper right corner, but it's always one that a whole bunch of individuals in the internet have classified as representing high energy and positive affect. So you open this up, you tap on the one that represents your mood.
This is base studies, but expanded
Absolutely. And so in this context, because you guys already had a uniform measure of affect, there's one app that you can just use in anything. It's all open source. In any app you do or in web-based thing, you can just use PAM as an alternative way of getting more frequent affect measurements. So we riffed on this idea of that came from PAM, and J.P. Pollack, the author of that, is a researcher in residence at Cornell Tech. He spends half his time on startup stuff and half his time with us. And so together we riffed on this idea of when we started to look at pain. I don't remember how it is that we started to look at this question of pain, and we got a little stuck on this issue of how it is that people measure pain and even ask for people to report on pain, right? Some kind of pain intensity scale or emojis, right? From happy faces to others. So we thought, can we take some of what was interesting from PAM and apply it to pain, and take this concept also developed by your community at large of notion of activities of daily living, and use images quickly tapped on through touch screens to help people report on pain interference instead intensity, and talk about what activities of daily living were interfered by their pain as an alternative way of getting people to give some indication as to whether treatment, feedback into treatment or indication of a flare, right? Depends on the condition. And it was also sort of at the beginning of Tinder. So it was sort of this notion of initially on board by, swipe left or right as to whether this is even a signature activity for you. Is this thing difficult for you on a difficult day? So we renamed this thing. We call it adaptable visual assessment. And people are looking to apply it in different contexts, and then they will have to validate it in that particular context, okay? And the idea is, so we went to all the things that doctors ask for people with lower back pain. For example, what are the activities that are difficult? We also went to patient blogs where people talk about lower back pain, and we took those particular activities and we give a big inventory to somebody. So that if you don't ask about riding a bike, if you don't ride a bike, getting on a bus, if you don't get on a bus, using a cane, if you don't use one, right? People just talk about what is their signature activity, bending over to wash your face, putting on your socks, these activities. And we do that with images. That creates that's the full assessment that can happen once or once every something. And then the spot assessment, which is as frequently as you want it, is tell us which activities you had difficult with today or this week or whatever is the frequency you want to do it. And they simply tap on those, and that becomes their data point of inventory for feedback. So we did do a little, there was a lot of stuff going on in one of these initial explorations. It was not a randomized clinical trial or anything like that, but we worked with a physiatrist up at Hospital for Special Surgery who looks at alternative ways of treating lower back pain. And they have standardized questions they ask about back pain, the ODI, and there's some correspondence between this, but to really validate it requires more particular studies. And now we just make this thing available. So we have a clinician at NYU, a cardiologist who looks at rehabilitation for after our cardiac events and getting people up and walking again, and he's using it in a version of it. Different set of images, right? So you just decide for this thing that you're trying to understand, what are the set of questions or activities that you're curious about. We go to Adobe and grab down images, and we repopulate the application with that data. There are some sports injury people also at NYU who are looking at this for dancing injuries. It's just a very, very low-tech way of looking at self-report. Okay. So beyond mobile location activity, various things from wearables, voice agents, more modern forms of self-report that are very low tech but timely. There's also these broader digital traces that I alluded to, and those are things like purchases, the other things that people might self-medicate or binge on, right? Netflix binging, Tinder binging, whatever is the binging of that particular person, as well as location language use in email or whatever is the medium that they communicate with online. And there are aspects here that are quite relevant and maybe most relevant to aspects of psychiatry. So one of the things that is the most work in progress, I can't call it hot off the press because it isn't hot off any press from a publications perspective. It's just things where we've started to build and are trying very early exploratory look at this, is the opportunity to get access to some of this data, but retrospectively. So one of the frustrating things and why things are slow to proceed is because all of the data using wearable or mobile phones are prospective. You recruit people in, they download your app, you give them a phone or you don't, you give them devices, and you start collecting them prospectively. You don't have that granularity of data for them retrospectively, so you can't do any big data things the way you could and can, and you guys are doing with electronic health records. You can't play that game in things that are just prospective. So, retrospective data learning, a fancy name for this concept, which a number of folks are looking at, is the fact that we've been online for long enough, and we have several dominant platforms that have been saving this data about for us. And some of those platforms, one of them in particular, is very good about giving you access to that data. So Google has something called Google Takeout. You can all go on and log on to your Google account, and you can look at it's not all the data that has it, but it is the data that Google does retain in your personal profile. And that's access to, depending on what kind of phone you use and app usage and whether you're paranoid and you sort of do clamp down, don't give location settings, right? There are some reasonable, don't ask me for the number of individuals, percentage of the population that doesn't turn off location settings. And in Android in particular, there's a lot of that. And so from Google, you will see your search and your browser history, and you can get access to your search and your browser history and location data. Perfect? Not at all. Just like some days you might leave your phone at home, right? Not perfect, but so much more pervasive than anything we've had in the past. So it's noisy, it's bursty, it's confounded with a bunch of stuff. It's riddled with privacy issues. But it's too rich to not look at from this question of the ability to now do something retrospective over the last 5 or 10 years from individuals, to do that kind of a study and begin to look at whether, in fact, that also gives us a clearer idea about what to do for prospective studies. One of the problems with prospective studies is not just is it everything prospective? You don't have much data on which to do a smarter job of pulling out a real digital biomarker from the noisiness of the proxy data you're getting. So it could be that I'm just most interested in this because it's the newest thing, and so I'm least disappointed in it. But I am quite excited about it. And what we're doing right now is just looking small numbers of collaborators in some different fields where they would recruit in. So to use this, we created a data pipeline where the individual who's being recruited in under an IRB-approved study, right, goes and authorizes access to these retrospective data sources, does Google Takeout, but we don't want to bring it down to a laptop or we try to leave it in the most secure place, which is, for better or worse, Google. So it goes into their private drive on Google, and that's where analysis runs. And what you want to do is not keep all that raw data. You want to pull out, for example, looking at those parameters of the diameter of their day, diameter of their week, variance in the diameter of their day or week, time out of the house, hours out of the house on weekend, those higher level, rather than keeping their raw location data points, you want to pull out these higher level features and then look at that. And if you have clinical records for them, so the idea is that for individuals who have been diagnosed, you have clinical records, who are interested and willing to be early participants in exploring this, You get people with clinical records and this retrospective data to begin to explore to what extent and how can we use these data traces. So we have looking at, for example, lupus, where there it's interesting because symptoms appear long before diagnosis in many cases. IBS, IBD, differentiation is another interesting opportunity. We're also looking at cancer patients during treatment, readiness for surgery, things like that. Could it be used in useful ways? So in all these cases, across the mobile, the wearable, the self-report, this retrospective data learning piece, the hard part is figuring out how to actually extract something that you could, in some valid and robust way, use as a digital biomarker, even if it is relative to the individual's baseline. It's still difficult because in the same way that the attractiveness and the scalability of it is, and the adherence likelihood of it is all because people are using these things for other reasons, not for you, that also makes it very noisy. So coming up with interpretable, actionable, and reliable measures out of that, in some ways, there's a lot of commonality, right? I don't know how many specialty disciplines are represented in the room, let alone, Columbia Medical School more broadly. And for particular cohorts, populations, conditions, right? It's different for Parkinson's than somebody with general anxiety disorder. But there's a lot of commonality, and then it requires going out and saying, how do I use it in this particular condition and cohort? So this was all very slow. I was almost getting ready to give up on this because really the lack of actual evidence about this potential gets a little embarrassing after time, because if there's so much potential, why aren't we seeing more evidence yet? So, some of this is academic process. First of all, just health is so much harder. What you guys do is so much harder. But I think even beyond that, rapid iteration, adopting existing consumer components and figuring out how to use them, a lot of that was slow. But I think there's been more hope that's come on the horizon in the last couple of years, in particular because of ResearchKit. So Apple announced ResearchKit in 2015, and Robert Johnson funded us to do the open source equivalent for Android, so you don't only have to do clinical research on people who can afford iPhones. That doesn't seem very relevant in New York, but outside in New York City, where you can't afford to live here if you can't afford an iPhone, but more, New York City is absurd in terms of its percentage of iPhone users, and doctors are absurd, are just outliers in terms of how many of you actually use iPhones. But the rest of the world, the rest of the country, I think in some ways the rest of the state, there are a lot of Android users and they're much more affordable models, so that's just an important detail, but it is a detail. So back to what was important about ResearchKit. How many of you know about ResearchKit? Great. And so if you don't know about ResearchKit, there are two apps in particular, some of the early ones that I think are most relevant and really interesting. One of them is the Parkinson's app, and another one that came a little bit later is the autism app. And so Parkinson's app has individuals. And of course, this is most interesting when these are individuals who are recruited by their doctors for whom there is clinical data, right? So, but the app itself took existing clinical measure like the tapping test and designed an equivalent using tapping on the phone. Took the known test of saying and measuring, because the medical research had already shown, finding evidence of the state of somebody's Parkinson's in their voice signals out of their vocal cords. And so you can capture that data and do that analysis on the phone. So a great example of an app, as well as things like walking and such. And what was important about ResearchKit is it gave a common framework so that you don't have to go out and just start all over and get some local designer app person to build something for you. It has established a common framework for people to use, so there's more opportunity of using the common components. The other important thing about it is that Sage Bionetworks put a little bit of a benign Trojan horse in it, which is to say, back to my comment, it's still difficult to figure out how do you interpret this as consistently as you do this, not only because it's different, but also because this is now something you could do daily or a couple times a day, you know, before medication, after medication, late after medication is worn off, right? To look at the variability in that motor function. And it's not, and very algorithmically, statistically simple approaches are not as good as more sophisticated ones. And they wanted to get the data available to researchers more quickly than the medical community has evidence that they do if you don't put in a Trojan horse. And what they did was to say, you patient who downloads this study, participates in the study, you can opt out of having your de-identified data shared, but the default is that you're opting in. And most individuals allowed their de-identified data to be shared through the Sage Bionetworks data platform. And in fact, a year after launching the study, they published public data that researchers could go in and then study. The other app I want to mention is the autism app. If you guys looked at this one, it's really brilliant. It's out of Duke. And the idea there is it's not again, standard clinical practice. The standardized videos, initially interactions, I think, which were then videos that you have a child observe and a trained individual watch their reaction to this social interaction. So the child sits on your lap and you hold the phone in front of them and you show them the video. And the camera, right, the self-facing camera, the selfie camera, records the video, has the precise timing of the video it's playing. So it takes the images of the watcher and lines that up with both the facial expression, the turn of head, and precise timing. So the ability to extend that observation of child in response to known stimuli, right, that you guys developed. And so just think about many other things you might do with that, whether it's, you know, stunting tests or what have you. Really brilliant use of the fact that there's a camera on the phone that's playing the videos, and computer vision is well at the state that you can do that interpretation when you know what you're looking for. Okay, I told you that. So I want to mention one more of these. Fred Munch used to be at Columbia, right? Then was at Northwell, is now at Partnership for Drug-Free Kids, a recent transition of his. While he was at Northwell, and he was PI and still is PI on this study, basically trying to do a digital marshmallow test within ResearchKit and ResearchStack. So taking, again, standard measures that you guys had already started doing online or on a computer-based, and studying whether their equivalents that appear through the app are good measures. I don't have the results for you yet because they haven't been written up and the data is still being analyzed, but it should be coming out and available in the earlier part of next year. Something else we did alongside that was not just to take the existing clinical measures, we also said alongside this 100-plus person study, let's try to get some passive data from individuals to see if we can explore what Fred brought to us as sort of anecdotal observations, sort of the equivalent of pressured texting, right? Not pressured speech, but pressured texting. Could you pick up any of that? Or other indicators that might be, such as screen lock-unlock. So that's sort of, we all have this most of us have this, I think, at different times, right? Where we get overly focused on unlocking our phone and checking for things, right? But then could this be an interesting indicator for people? And so that's just also data that we're analyzing alongside this. So there we have these active tasks that are your equivalent online measures, BART and other things like that. And we're collecting passive data to look to see if there is a signal there, if you will. So I want to sort of now wrap this towards wrap this up and have times for Q&A and stuff, but there are a few more things I want to say. So one is also this is work that I think Naiwa Dwan, was he here or in bioinformatics? Biostatistics, yeah. So I think he was one of the first people who worked on statistical approaches to N of 1 study design, and I met him sometime when I was visiting in New York before I had any idea I would end up here. And that whole notion of actually bringing this into care. So there's doing research that looks for N of 1 variability, but there's then the notion of that many of the things you do, you're prescribing things that people will be on forever, right? And you have to go through your empirical process of doing that. And can we bring that empirical process more systematically to more things with more objective measures by using the things I was just talking about? So N of 1 is not something that tech designed or created. It's simply something that all the things I've been talking about could help in terms of capturing the data that comes out of N of 1. And then ultimately, how do we bring this stuff back into tools for individuals, not instead of care, but in between, extension of, and all the individuals who have challenges that don't ever get necessarily actually treated, or where a component of what you recommend people to do has something to do with behavior. So how can we help people with health behavior that is a component of so much clinical care, unless you've given up on health behavior, right, understandably, and the things that are most addictive in the environment, right, alcohol, food, and drugs, right, can we do anything to help individuals improve those behaviors? Sleep, probably another one. Digital addiction that interferes with sleep, others as well. So I think there's a lot of interesting potential to try to tie these things into those behavioral feedback loops. Okay, privacy. I don't know, did I make anyone nervous at any point in here, or you think about this stuff all the time anyway? So you can either be skeptical because you think your patient population who care about privacy or are paranoid about being tracked, or you can just say, okay for them, but not for me. And what do we do about privacy? And I don't have, for a while, for some number of years, I said, well, the data are being collected anyway. Google's, Amazon's, et cetera. Okay, we should all care more about that, but given that most people don't care more about that, if an individual consumer could get those data to be useful for them, not just to sell them something, right, that's not, I haven't increased your privacy exposure. I don't know about that anymore. And things like this, we're doing this impulsivity thing, and Helen Nissenbaum has come to Cornell Tech, and she's a brilliant philosopher and ethicist around privacy and privacy by design. And I literally woke up from a nightmare. It's one of the only sort of this grandiose nightmares I'd had recently, because I had read Stat News the previous day with this article about how if you do your, spit into a tube and have your genome analyzed by, as part of a employer-funded wellness program, that your employer has access to that data despite GINA, which supposedly protects us from being discriminated against, insurance and other things based on our genetics. So I had read that article, and Helen said, well, you're doing this impulsivity measure. Well, that's great, but that's just going to be used by advertisers and folks to just lure you into whatever you're trying not to do at the time when you're most vulnerable. And then if you're doing this impulsivity stuff, think of its use in HR, in promotion. I don't actually know what to do with this confusion of what to do about the utility of this in care and our vulnerability to it being abused. And then just the thought of also, a lot of things were going on at the end of last year. And I have this thing about, I'm not really a fan of mail-in voting because you're not in a secret ballot. And I worry about individuals who can be pressured by domineering people in their lives to show them their ballot, which doesn't happen in the ballot box. So I was thinking, from this perspective as well, you could be asked all your plausible deniability about where you were, whether you're in a situation of domestic violence or otherwise. It's problematic, this thing. I don't have an answer for it, but it's not appropriate to not mention it. Okay. And there are things that we're trying to do to figure out ways of bringing more policy-based architecture into things, being able to know more of what you know, but I have no panacea there. So I could say something about Cornell Tech, or I could stop and I look to my hosts and they should tell me what to do. Great. So Cornell Tech, this shiny object in the middle of the East River. It started at the beginning of 2013. I was the first academic hire. I was not the first hire. The first hire, Dean Huntenlocker, who runs that, ran the process and runs the whole thing, hired first a chief entrepreneurial officer before he hired a professor. And I mention that because it's correct, but it's also indicative of how he and the whole process was trying to shift what is the basis of highly impactful academic work. Since that time, we have more than 25 academics in full-time. So in our discipline, right, we don't have clinical practice. We all have 9-month salaries, and usually from research funding the rest of that 3-month. But it's our full support. And we have academics who could be faculty anywhere, largely in the digital disciplines, a lot focused on particular in cybersecurity and AI and HCI, human-computer interaction. And we incubated in space that was lent to us by Google. So we started with 7 students, and then we grew to a bigger class, and we made up the program a little bit in advance of when we were delivering it, and we grew from 1 master's degree to 7, and we increased our PhD students as we increased our faculty. We all have appointments with Cornell. I'll tell you. Good question. So and it's all tied to what I was about to say, which is that we all have appointments in our home departments in Ithaca. And Ithaca has fantastic, highest, rankings, right, in computer science and information science, operations research, and electrical and computer engineering. There is also business and law, but they don't really have the same PhD students. So we have master's programs across those things that we don't have undergrads, we're graduate only. And then the faculty have PhD students who are all part of the PhD programs in Ithaca, students who move down to work with us as they get started on their research for the most part. Different departments are different, are slightly different across those different technical disciplines. And we moved to the campus 3 months ago. So AI, data and modeling, so operations research and electrical engineering more focused, security and privacy, and what we loosely call social computing and HCI. And we have a 2-year master's program. Most of those are 1-year masters. We have a 2-year master's program, and that's where health tech comes in, because health tech is one of these 2-year master's programs. And I want to mention this because these are individuals who are technologists. They take all the masters in computer science classes, but many of them come in from pre-med, actually. People who went through pre-med, they had taken AP Calc, they're mathematical, and they encountered programming and stuff along the way. But they decided for whatever reason they weren't going to go on to medical school. A whole bunch of them have mothers, fathers, aunts, and uncles who are doctors. Okay, so they got them to go into pre-med, but then, right? And what are they going to do with a bachelor's in biochem? Whereas if they're interested in digital and data stuff, and then I give them a set of classes they have to take that's sort of a bunch of the equivalent of a CS minor, they can come in and take these classes and rebrand and come out as somebody in this health tech space. So they take classes in healthcare and a lot of sort of practica, because they don't so much want academic classes, they want exposure to clinical stuff that's going on. And they do a 2-semester deeper dive specialization project, and they could do those things with you. So they do them with folks at Weil, they do them with startups, they do them with larger companies. But it's a very interesting opportunity if you have a practical idea, not ready for NIH funding, right? Or been rejected 3 times because it's somehow risky and until you have validation, you can't do it, right? It's a good opportunity for working with our students. So an example of a project that was done with the cohort that's going to finish next semester, so they're just finishing their second semester in the specialization project, was something called Magic Mirror. They now call it reflective health. And this was using computer vision to do mold detection for a smart mirror. Now, one of the reasons we did this smart mirror, imagine a smart mirror with computer vision like that autism app in your bathroom, right? Nobody there can tell me that there aren't privacy concerns. Everybody agrees that interpretable pixels should not be seen by anybody but the person standing in front of it, right? So the push to do local processing so that all that comes out is that maybe there's a mole that has changed or not is the only data point that should ever come out of this thing, right? But it's also an interesting place to try to engage in adherence or get a sense of affect or some of these other things. Is it ready to be a product? Is it ready to be anything you would use? No, but it was something that they could explore and iteratively prototype. There's one of the spin-outs as a startup out of the computer science program, which is just 1 year, is I brought this up for obvious reasons because it's a little bit adjacent to what you do, is a speech therapy app for kids. Another one of these contexts where you would like much more frequent interaction and make it more fun. Don't leave it to the parent. Don't rely only on clinical encounters. And they're an active startup. Let's see how far they get. It's a really great team of students. Two of the founders grew up with speech impediment, and so they come to it authentically. And now I'm done. That's it.
Deborah, I hope you don't mind we're on a first-name basis. This is enormously exciting as well as also entertaining. I guess I'm not the most facile necessarily technologically or in terms of computational person, but what I'm confused about, or not confused, but just wondering about. So you have this enormous technological capability and also using it to acquire massive amounts of data, which can be used in a variety of ways that are beneficial and constructive. But it's not clear, like, are these like products to sell to make money? Are these things that are to be incorporated into healthcare, and although they have to be financially viable? So, I mean, just to take one exemplar of an industry that's had to kind of heal or yield to the social imperatives of getting into a business of health is like the pharmaceutical industry. So the pharmaceutical industry, their products are medications mostly, some devices, but they have to go through this rigorous FDA process and so forth and so on. And then you have devices that do it also. So in this case, for that to sort of move into that area and be something more than recreational, some things have to happen, but how are you thinking about that?
Thank you. That's a very good prompting question for clarifying. So there isn't one answer. It comes down to now. So this, what I generally am talking about is there are a bunch of capabilities out there that, first of all, you as researchers could explore how to bring these things into clinical assessment. It could be because you're looking at some new pharmaceutical product or some device product or some form of therapy, and you want to get an accurate assessment of what leads to better outcomes.
Well, let me stop you right there. Okay. Yes. So there's the engagement with academia, in this case, academic medicine, to test something that you clearly see a potential use for. Okay. Where's the funding going to come from to do it? It's not going to come from the NIH. It usually in pharmaceutical development comes from the pharmaceutical company, but that has strings attached. If it's going to come from Google or Microsoft or Apple or any of the companies, they may have industry-sponsored stuff they want done that they could have academic medical departments do. Yep. But there's no identified source of funding to really prime this process.
Yeah, that's part of the problem. Okay, but let me, and I don't want to just end there. There are different points of interjection as well. But on that one, at some point, NIH will stop funding things that don't.
No.
What am I going to say?
It's a zero-sum game.
Wait, stop. What am I going to say?
They're going to have to start funding stuff that pertains to this.
No.
Sorry.
That's okay. I do the same thing.
My wife finishes my sentences, so I just sort of think I could finish everybody else's sentence.
Right. Interesting comment. But anyway, I won't go there.
You're already becoming a psychiatrist.
Things about that comment. Okay, what I wanted to say was that the studies you guys do, that you have done, and that you hope NIH will continue to fund, need to modernize what they're doing and have better, more accurate forms of assessment. And some of these things will come in because these are the tools of your trade now.
I have one thing to say to that.
Yeah.
SBIR.
Yeah.
That's the only mechanism.
Well, I'm not a believer in only one of anything, particularly across such a broad range, right? So when you're doing clinical studies under NIH funds things where people are using mobile health or other digital tools as a part of funding something that NIH should be funding, right?
Where's Alacrity being done, Scott? Is that an NIH or PCORI? NIH. So you're right. Okay, so Scott is...
But I don't think we're universally... There's also a lot that's correct in what you're saying, because there's not one answer here. It is difficult, okay, to figure out where the stuff gets funded. Then there are startups. And startups are a weird phenomenon, right? Particularly when it comes to healthcare. It's some way in which it turns out to be convenient to the commercial ecosystem to have innovation happen, or for VCs to sort of gather cannon fodder for investors, right? Most of these things fail, and none of the work that was done along the way goes anywhere, right? Because it's locked up in proprietary stuff. But some of them actually get used. So look at Omada Health, right? It was, I just saw on my favorite source of news, right, Stat News, that Harvard Business Business School has a case report on Omada Health, context of diabetes, and the DPP was done and tested, I don't know, however many years ago, right? Diabetes prevention program, and they've done sort of modern incarnations of it because it's in somebody's commercial interest to reduce pre-diabetics becoming diabetics, and so there's some money food chain thing that you can follow there to help the providers or the people building systems, and they come from a range of different directions, whether it's IBM trying to create use of Watson, right? And so they are trying to incubate a bunch of product development ideas that are just downstream that will come and use Watson. So there are lots of things in the commercial ecosystem where somebody is trying to make or save money someplace, and this will happen, some of it through commercialization. The problem is that some of it will happen through commercialization, completely ignoring the work you've done, right? And they'll either do something that's just stupid and might fail or might not fail because the problem was somewhat easier. But now we're starting to see some more careful work of people looking at best practice from CBT or other things that they are trying to bring into these products in a more specific way. And I think it's I said this before in a smaller group. I think it is, if you want to remain an academic, doing the creation of knowledge of how best to care for people, and you want to see your stuff actually go out and help larger numbers of people because it moves into product, and you want to get revenue from that process, I think that's very difficult to do all those three things, right? So you can be an academic, continue to do research, and you can advise other people on how they can make money. It's very difficult to build. An SBIR can get you a little bit farther on this, but it's very difficult to build and maintain a consumer-facing, robust, good-to-use product if you stay just as sort of SBIR.
I don't think the problem is on the academic side and being willing to partner and embrace. Yeah. I think it's on the corporate private sector side, not having sort of engaged sufficiently. But at any rate, let's open it up so we can let some other people. Myrna.
See if I understand this. When you do clinical trials or you do any longitudinal data, you follow individuals over time. And we have lots of tools, symptoms, social functioning. You could do those through apps when the patient goes home rather than just in the office. Yep. Those tools are all there. That wouldn't be hard to do. Yep. And some people are doing it.
Yep.
So it's all there, and that means tracking individuals.
Yep.
But when you're looking at big data, like the GWAS studies,
yep.
then you're talking about not this kind of collecting of data. You're talking about the analysis of data. And instead of analyzing big data cross-sectionally across individuals, are you saying they should be analyzed per individual? In other words, tracking the individual over time.
I'm back at the first part of it, okay, which is that, okay, you think your tools are fine and good enough and predictive enough for you to do your studies and do your treatment of care. Nothing I said is relevant to you.
No, they could be better.
Okay.
But the way they would be better
Yeah.
would be to take some of the same concepts and have them move out of the office. Because out of the office, the patient's in the office a little bit.
Exactly.
And out of the office. So if
That's what this is for.
So that's what you're talking about with your
That's
father.
what I'm talking about.
With your father.
Yes.
Yeah. Well,
Or in any context, right? In other contexts, is
Yeah.
to be able to get data, indications about symptoms, side effects, progress of condition, effect of treatment, whatever it is you're trying to measure, input to the clinician to give them a better view as opposed to only being reliant on self-report.
Okay, so the problem there is you can improve the tools. The problem there would be input. The programmer who's going to put that in, or having the tools in such a way they could be input into a clinical record so the clinician could look at them.
The data are all generated automatically, all uploaded automatically, and all interpreted automatically. And when I stopped and said the difficult part is coming up with the specific algorithm by which you interpret some noisy combination of activity level, social rhythms outside the house, language use, and some kind of, self-assessment, right? How do you combine those things into a relevant measure for the clinician who's looking at for the report? That's where the technology is all there. You don't have to get it. Nobody has to input it. But you then have to take for your specific populations, how do we then use an interpretation? Where are the features we pull out of that noisy data? And that's where I got the question, who's going to pay for that part of it? Which is a very valid point.
Right here. Wait, talk in the mic's on.
Can you hear me? Okay. So I was wondering, so in addition to privacy, I know some concerns are like with the use of technology sometimes exacerbates like certain conditions like anxiety.
Yep.
Like when you guys were talking about speech therapy, like I know that there's an app like BetterHelp where like that's one of the main controversies. Like when a person's looking online and consistently using it as a form of therapy, it's also like helping with their anxiety, not getting them to communicate with other people and be more addicted, and also like for like neck issues. And another concern that I know that was talked about in a lot of your community is like using technology for like geriatric population. They don't really understand how to use it. Even like ones that like a live core for like the EKG, it just doesn't work.
Yes. So both important points that we need to design, iterate around, right? So those sorts of friction points, I don't dismiss them, but I think we have to figure out in the cases where people do use them, first of all, what's the signal in it that we can use in care? And then we have to see how do we bring it to a broader population, and what do we do about the first thing you mentioned, which is these unattended consequences. There might be contexts in which somebody has a condition in which this is contraindicated. You should not use this for people with, probably certain kinds of eating disorders and other things, right? You have to do a very different, nuanced approach to that. But I think there's enough, as the tech industry likes to call it, like low-hanging fruit of places where there's a lot of plausibility on your part and you've already done some other work to try to use it, keeping in mind that there are other things that have to be done to expand them. For older population, I think in some cases it's a tablet that is maybe associated with the informal caregiver. Maybe it has nothing to do with the older person and it's only their informal caregiver. And some of these voice agents are sort of interesting to look at. But all the points you mentioned are really important. I don't think they're reasons not to start. They're reasons that we have to then work around before we can be confident about generalizability and safety.
further example of exactly what you're raising is with this medication that was just approved by the FDA. So it has a sensor that is being given to people who are psychotic, who often have delusions about being monitored and followed and everything. So is Paul Applebaum here? So Paul had a nice quote in the New York Times article of saying exactly that. You know, it's ironic that the first treatment of this sort happened to be for people who have schizophrenia.
Yeah.
Ned.
Thank you, first of all, for a wonderful talk. You alluded to this, but it's not on. It's not on? Sure it is.
It's not close enough
on?
to your mouth. It's not effectively
All
on.
right, can you hear me? Okay, so you alluded to this a little bit, but, you know, in our field, in terms of an evidence-based something works, particularly a therapeutic intervention. We do randomized clinical trials, and we do longitudinal observational studies. They take a long time to do.
Yeah.
And the technology moves really fast.
Yeah.
So, for example, we were involved in testing a technology-based behavioral intervention that was invented in about 2005. The first clinical trial came out in 2007. We were involved in a big clinical trial that actually led to FDA approval of this thing that was published in like 2013 using 2004 technology. It was on like a clunky computer. So the question is, can you think about, are there ways, and relatedly, one of my colleagues published a literature review looking at how many apps are there out there for substance abuse.
Yeah.
And it turns out there's dozens of them, scores of them, maybe hundreds.
Self-proclaimed apps for substance
Self-proclaimed, only one or two of which really have what we would consider evidence from controlled trials. So have you thought about, is there a way that you could launch something and then some fast way to test the effectiveness of things, perhaps by launching it in such a way that data is gathered from the users that supports effectiveness?
So it's a big question. So first of all, there's an easier version, which is just a smaller part of the problem, which is I'm not talking only about things that are actual interventions. These are measurement techniques that other ways you've already have clinical evidence on interventions, and this can be an alternative way or a scalable way of deploying your intervention or of measuring the effectiveness of an intervention in a new population or over a new period of time, okay? An actual digital therapeutic, okay, and even in that context, right, when you write into your proposals there is that there will be some iterations on reformulations, right? The statistics get messed up, right? You have to take care to those things, but it is doable. It doesn't take away the fact that you don't know the long-term effect of something until you observe it over long term. But it's only in more recent decade that a decade ago, I would give a talk like this and the whole conversation would just tank on people only have text messaging. So stop talking about smartphones. Okay. Or people will never turn on the GPS. The GPS was outside the phone, right? All kinds of things like this. So that it's crazy how rapidly that has all evolved. And so it is an interesting question. How do you write these study processes in your experimental design when the underlying deployment mechanism changes over time? It's people change medications, right? The formulation, and they shifted from a brand to a generic formulation, or some new drug came out and you're studying long-term effect of whatever the condition is, you do change the formulation that's used in the study, or some new discovery is made, or right? So it's something along those lines, but you have to know that even though things are not now stable. Now that there's so much technology in consumers' hands, this will be something that needs to iterate, and you need to build something in to make it not completely ad hoc and impossible to track.
Well, with that, we're going to transition up to the 6th floor for our lunch. Let's all thank Dr. Estrin.